and then a couple of applications of linked lists, right? Reversing a single linked list. We discussed that in the last couple of classes, so I'm not going to cover that again in Unit 3. We have already covered that. Another classic case is we use single linked lists to represent polynomial expressions and also sparse matrix manipulation. So we'll in the next class on Monday, your time, we look at some details of showing the polynomial expression representation using a linked list and sparse matrix. Okay. But today's class would focus on revisiting what we have learned in Unit 1. When we did that, I mentioned to you that I will be visiting this again when we cover Unit 3. So pay close attention. And as always, we will have the interaction, and I want students to help. Last session that we did yesterday was quite exciting to me because there was a little bit more participation. I guess all the scolding that we did, gentle scolding that we did, kind of helped. So let's have more participation and let's have fun together. I'll put it in presentation mode. Okay, I wanted to start off with a quote as always. Where did my chat go? There it is. I love this quote by John Holt, who passed away in 1985. He was one of the US guys. Learning is not the product of teaching. Learning is the product of activity of learners. So again, it keeps, if you notice, I keep re-emphasizing it's about experiential learning, right? You learn by doing. The good old days, teachers had a certain role, but in today's world, the teacher's role is that of more of a coach and a guide. We are not here to give you each and every gory detail, right? You can figure these things out amongst yourselves. Go look at Google or Google Scholar. Talk to your peers, right? And then we are there in the classroom to kind of give you some coaching and some pointers, okay? So this quote goes very well with that. I really like the second one too. In case it's a Chinese proverb actually. Remember how I keep saying, go ahead, ask questions, don't feel shy. I learned these things from my mentors and others too, right? He who asks is a fool for 5 minutes, but he who does not ask remains a fool forever. So it's always a good idea to asking questions. You know that if you, sometimes in a WebEx type environment, when you have a lot of students, it's a little bit challenging to ask questions. But there are other medium now, right? You can ask questions in the community. You can ask questions after the class is over with your mentors, right? And you can certainly ask some questions in the chat. So I'll try to answer as many as I can. Okay? Okay. So let's get straight into the matter. Hopefully I can breeze through this fast and give you back some time today, okay? Since we covered this material in some level of detail when I did Unit 1, okay? So here is a formal or semi-formal definition of linked list, okay? It's a linear data structure where each element is a separate object, okay? Now when we talk about object, it's that each element is a separate object. What we mean in programming terms is a node. Now we use the word node quite a lot in this class when we talked about linked lists in Module 1. Okay? And what does the node contain? It contains 2 items. Okay? You have data, and then you have a reference to the next node. That's what we call it a link. Okay? The last node has a reference to null, meaning you have reached the end of the linked list. That's what it means. Okay? Null represents there is no more to continue. Okay? And then we have seen this concept called head. Okay? That is the entry point into the linked list. Okay? It points to the head of the list, as we call it. Okay? Now, from a programming viewpoint, you should note that head is not a separate node. Okay? It's just a reference to the first node. Reference is address of the first node. Now, if there is no list at all, then the head is a null reference because there is no node to begin with. Okay? Again, after the class, I'm going to put this in the community. Okay? Okay. Now, right off the bat, I'm asking you a quick group question. Okay? You can put it in the chat. When I first introduced you to the concept of linked lists after we covered arrays, we kind of discussed what are the disadvantages of arrays. Okay? So can somebody list a couple of disadvantages of arrays in the chat and put it for everyone? To just refresh your memory to get your feedback. What are the disadvantages of arrays? Because when we covered linked lists, we first listed some disadvantages of arrays. Faculty member, you can ask your students there and see if anyone gives an answer and put it in the chat. Okay, in array static allocation of memory. Great. So let's take it a step further. So what is the big deal about static allocation of memory? What disadvantage it can lead to? Yes, it is static allocation, but what is the disadvantage there in static allocation? Very simple answer, right? If the static array is, let us say, 50, 50 is what the index is, right? A is 0 to 49, 50 element array. For an array, we need contiguous memory allocation. Okay, that's another one. And we may not get contiguous memory. Is that what you imply? That's what I assume you are implying there, right? So when you have static allocation, if your number of elements that need to be put in the array is larger than the array size, then you are stuck, right? You don't have more memory in the array. Similarly, if your number of elements that are less than what has been allocated, you are wasting memory. That's another disadvantage. Another disadvantage is, let's say if a sorted array, you want to insert an element into an array. Then there is more work to be done, right, to insert an element into an array. Especially if somewhere in the middle of an array, how would you do that? Okay. You have to rearrange the elements, each and every element. So a lot of disadvantages like that. It is precisely because of that we found the need to have a linked list. Now, in linked list, we have seen enough examples where we did a dynamic memory allocation, right? So you allocate memory only when needed. Big advantage over an array. And since it is logically linked, each block is logically linked in a linked list, you don't need contiguous memory allocation. As long as the pointers are pointing to the right node, you are good. Insertion into the array becomes let me take back. What is the disadvantage of a linked list? Is there any disadvantage of a linked list? Name one. JTV, your turn. Name one disadvantage of a linked list. This is a very legitimate internal exam question. Think about traversal. In array, no matter which element you access, it's of the order of 1, right? whether you access A0, A1, A49, it's always order of 1. Immediate access, correct? Whereas in linked list, if you want to order, that's a good disadvantage. If linked list pointers need more memory to hold the address of the next node. Exactly. Yes, absolutely. Because since you're saving the link, if you want to get too technical there, depending on whether it's a 32-bit architecture or 64, or depending on the word size, typically it's a 4 bytes. For every node in a linked list, you need 4 additional bytes of memory. Okay? Let's say it's a 4 bytes of memory basically. That's what you need. Okay? 32-bit architecture. Okay. And the other disadvantage is, let's say if I want to find a node, if I want to insert something, I have inserted, let's say, after n elements and things like that. You do not know where the element is, so you have to traverse all the way from head to, or I would call it more like find, right? You have to traverse all the way, follow the links to find the right place where to insert an element. Okay? It takes a little bit longer to traverse the linked list. Okay? So these are a couple of disadvantages of linked lists, but in general there are more advantages to a linked list than an array. Let me go to the next slide. Okay. Now, by now you know the modus operandi, right? When we talk about the structures, we talk about the basic operations that you perform on a structure. We have seen it with arrays, we have seen it with abstract data types like queues and stacks, and we have actually seen it with linked lists from module 1. I'm just rehashing what we learned there because I'm 99% sure you forgot what you learned in that module. Okay? So typically basic operations are insert, delete, display, insert. Okay? We recall this slide from the module when we talked about lists. Since you are supposed to be familiar with lists, linked lists from your C programming class, I said, okay, what does this code do? What is the output? Draw a single linked list and draw a double linked list. Right? So you can see on the left side here, typically how you declare a node. Struct list element. It has two things. One is value, that's called the data. And the second one is linked to the next node. And next node is also a node with 2 elements. So you always declare a pointer to struct list element, right? So first element points to the next element and so on. Okay? And then we said that we use the word type define, struct list L to item. That way later on when you declare linked list, in main here you can see we use the word item. So the type def essentially acts as a synonym. Instead of typing type def struct, instead of typing struct list underscore EL, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 character item every single time to declare a variable of that type. You just synonymize, give a synonym called item to that, and you declare item, star current, star head, and so on. Okay? And then we went through this code here, where I showed you how, in order to, head initially is null because nothing has been allocated, nothing has been initialized, right? So here you took a loop of 10 elements here, and then you are saying, hey, allocate memory, malloc size of item. Remember, we need the right size block to be allocated, and the right size block is dictated by the data type item. So once you allocate, okay, so that also becomes a current, and then that current in the allocated block, the value you're saving, the value of I. So the very first node that you put there, the value that is saved in this node is 1. Okay? And then current.next, wherever that value is, you are saving head there. Remember it has linked, and head is equal to current, meaning head node. Remember, head is nothing but an address. So it's a reference, it is not a block. And then wherever current is pointing to, head is given the same address. That's what. So you build that, you go to the third loop n times, and you are building nodes there. And each node, the value is going from 1 to 10 or 9. And then the next piece of the code shows you, start at the head. Remember, the very last node, the link would have null. So you go through the process here, and then you display the results of the linked list. So it should print out that 1 to 9 for you. Okay, we saw this. Just a refresher. So here are the representations of lists. So you have the one on the top shows the representation of single linked list. See how head is pointing to the data element there, first one on the left, and then next shows the link to the next element. Okay, and so on. And if you see the diagram below, which is called a doubly linked list, all it means is it has 2 pointers. One is to the previous one, and then to the next one. So you have 2 pointers, one to previous node and one to the next node. Okay? So if you recall, when we did this list, I said all you have to do in terms of list manipulation is you need to keep track of previous, next, and current. If you can keep track of previous, next, and current properly, any kind of list manipulation code deals with manipulating previous, next, and current. I should also say head. Okay? Something happened. Now, we also have this called circular. All circular lists is once you reach the element in the linked list, that last element of the linked list is pointing back to the first end. That is circular. You can use the concept of circular. Circular list. I gave you an example of the circular cube example in operating systems, right? Last time we did that. So you're doing some round robin type of algorithm. We typically use circular lists. Okay? When you do your operating system class, we will learn more about the circular. Okay. So just a rehash of the advantages and disadvantages of array versus linked list. I just left it in there. Okay. Now let's look at what are the operations, right? So we can insert into a linked list. Okay. So when you are inserting into a linked list, there are 3 variations of insertion, correct? You can insert at the very beginning, called top of the list. You can insert at the end of the list, and then you can insert at the middle of the list. Okay, values are same no matter where you do. It's connection of the pointers. So when you're talking about linked list, it's all about connecting the pointers right. So if you understand that logic, then all the basic operations of linked lists are a piece of cake for you. Okay? So let's look at that. So again, you have 48, 17, 142, 93 you are adding. So if you notice here in the picture, where is the 93 added? Initially, I want you to pay close attention. At the end, what is the pointer at the end? 142 element. It is null, correct? But /2 means null. Okay? And that null comes in hand in your traversing list. If you want to display all the elements, you will say while current arrow right link not equal to null. Okay? then you displace, because once you reach null, you know you have reached the end of the list. So here the pointer that are manipulated are the link at the end, the null pointer of 142. Now that null is removed, now it is pointing to 93. And since 93 is the last node, the link there would be shown as null. Okay. So whenever you are given this one, right? Typically, when I'm writing an algorithm for these things, let's say in the exam they ask me to write an algorithm for this, and then generally in a test, and to make sure my algorithm is correct or not correct, I typically draw a quick trace like this, and then I run through my algorithm with this test data. And if everything works out great, fantastic, I have the right algorithm. If something doesn't work out great, when I'm tracing, it's going to break my code, right? The algorithm, then I can fix the algorithm. So always just take about 3-4 element stuff like this to test whatever you're writing even in the exam. Okay. So we said we have to allocate node, right? So how do we implement a node? A linked list node. We talked about it earlier. Here is one more time. Is we need to declare a struct. Okay, the C programming. I'm talking from the context of C programming. How I do that in C++, even though I'll have struct, I would declare it slightly differently and so on. I would use the concept called a class, and within the class, the struct would become a subclass. But all those things are Greek and Latin to you at this point. So let's just stick to the concept of C programming. So here, there are two blocks, right? One block is the data. The next one is next. And next is pointing to the same structure again, right? Because you need both the data elements. So it's just pointing to the next node. It's a pointer to the next node. Okay? What did I say here? Okay. So keep this in mind. Okay? Practice a lot with respect to that. Okay. So what I have here, by the way, the way I'm going fast, I'm not giving you too many things to work on yet. The reason is I probably will end the class early and you can practice. Okay. We have literally one college here in today's session. So I'll try to wrap it up fast so that way you can practice. So what I did here was I copy pasted some good code from the internet, which shows you a C programming implementation of linked list with various functions. It has a lot more functions. I just selected a few functions. Okay. So what does it show here? First, if you look at lines 4, 5, 6, 7, close parenthesis 8, that is your linked list, right? You have a struct, you call it linked list, you have integer data, and then you have a pointer called next, which is pointing to the same struct. Four through 8 is nothing but what I showed you in the previous slide. Okay, no change. Okay. Now, if you look at line number 10, remember we use synonym, right? Every single time if I have to say struct linked underscore list, it's painful. So I just do a type def, and then I give a synonym called node to it. Okay, that's what I'm doing here. So going forward, I declare node equal to node 1, node 2, node 3. All of them are struct linked list nodes. Okay. Now, if you look at line 12, 13, 14, 15, 21, 22, all the way up to 26. These are all functions. Remember in C, you have to declare your function prototypes. Otherwise, the compiler is going to give you a compilation error. So what are the types of functions that you can do with respect to linked lists? You can say I want a particular, let's say it's a list list of all the names. I say, hey, give me the name Pratap Chilakanti, right? So that is get node function. Okay. Line number 13 is insert at beginning. Line number 14 is insert at end. We showed the pictorial representation. Now 15, if you see 15, it's an interesting thing. Okay. Let me think. Okay. So I'm getting a message saying we'll wrap up at 12:15 p.m. today. What is your time right now? 11:20, 11:50. Okay, fair enough. Okay. So if you look at line 15, you can see you can insert after nth node. We only did insert at beginning, end, and middle, but I did not specify what that middle is. I can say, hey, traverse 5 nodes and insert this as the 6th element. So you should not write code to go up the nth node. That means you should have some kind of a count, right? To count how many nodes you have traversed. That's what the trick part is for 15. Display. I already gave you some little bit of code there for display. You want to display all the elements of the linked list. 17 is a variation, similar variation like what we have seen in 15. You're saying delete after nth node. Okay. Now, where there is delete, you also have insert. Insert before nth node, delete before nth node. See the variations that you are seeing, the kind of, depending on the context of your application, all these things are valid. Similarly, insert after element. Code for to fit. I cannot fit all of them in one slide, so I break it down into multiple slides. But once I post it, you can copy paste this code, and it is working code. Okay. So you have the main function. Okay. Initially, pointer head. Remember, it's a pointer. Remember, because it's a dynamic memory allocation. So you declare a head which is of type node and is equal to null. What does it mean? Can somebody tell me what line 3 means? What is the meaning of line 3? That means no linked list has been allocated yet, correct? When does the linked list allocation begin? What statement signifies that a linked list node has been created? You can put an answer to that question. What statement signifies that a node has been allocated? Come on, you're all bright students. Is the question too simple? We have done so many slides, right? What is the first statement that you see when a node has been allocated? Remember this guy called Malak? I put it in private. I should put it in Malak, right? That's how the memory is allocated, correct? But here, up to node 3, we have not done it. We have just initialized the head pointer. And then whenever you initialize a variable, whenever you declare a variable, what is a good programming principle? Initialize the variable, correct? That's what we did here. Now, once we do malloc somewhere, this head would point to wherever that malloc node we got it from. We'll see that shortly. Okay. There are a couple of other variables. Once you trace the code, you'll understand. And then what in main, continuation of the main here, it says while one means true, right? You insert at begin or delete at begin. It is giving you code that you want to write. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 15. Okay. Based on what they enter the number, they will do the corresponding function. That's what this is showing you. Okay. Let me go to the next slide and show you a little bit more. Okay. And then after the user enters that one, by the way, what you see on the left side, 1, 2, 3, 4, 5, 6, 7, those are all line statements. Huh? So I just kept line statements there. So that way it's easy for me to explain on which line I am, right, if necessary. Okay. So switch on input, right? If it's case 1, if the user entered 1, you insert at begin. 2, you delete at begin, and so on. Okay. Now, when let's say the user entered at insert, signifying that they want to insert a node at the beginning. Okay. So now, if you study that carefully, you see it scans the number in line 6, right? Saves it in this variable called number, right? That address num means the user entered something, okay? And then since the number entered falls to 1, he's going to say head equal to, remember head has to point to the very first node, right? That is literally the first node, insert at begin. When you're inserting at begin, head ultimately has to point to insert at begin. So if you see line 7, it is calling the function insert at beginning. And what are you passing? You're passing the existing head, because you need to know the existing head, and then the number. Okay, whatever number they want to enter, insert at beginning. Okay. Same thing for delete at beginning. Okay. Since you're doing delete at beginning and insert at begin, head has to refer to those things. That's the reason why you see head equal to. Okay. Okay. So the rest of the code you can convince yourself on the slide like that. I'll go here. Okay. So if you see here, sorry. Okay. I want you to focus your attention on line number 9. Okay. Line number 9 is important here. That is the function call. You called insert at beginning. You pass the head. Initially, head is pointing to what? Null. Remember that there is nothing has been declared, nothing has been allocated here. And then whatever number you want to insert in that node is what you passed in int num. Okay, line number 10 is the open parenthesis. Now your task is to create a node, right? First, you need to allocate that node. So that's the reason line number 7 says, hey, I need to make a node first. So, and then that is nothing but a pointer. Pointer means address. So make node equal to get node. Earlier in the code, you simply saw me writing malloc. Here, since we are getting into more into structured programming, we always create a function even to allocate memory. In this case, the author is saying get node as a function. Okay, line number 12, I think get me the node, and my node make node is going to point to that. Okay. Now, if you go to line number 1 here, I want you to pay attention to line number 1. There is a get node function. So you are going to create that node. So line 4, you can see create equal to node star. That's called typecasting in C, because that's how C knows how much memory to allocate. Whatever the node type is, it's going to allocate that much memory. It's doing the malloc. So in line 4 is when the very first node is allocated or created. So the moment you create the very first node, what is the create.next link should point to? Because that's the only node, right? It should point to null. That's why you see in line 5 it is pointing to null. Okay. So you created the node, you return the address of that node, because create has nothing but the address of that node. So when you hit return create, where is it going? It is going to line 12 now, right? So now would the make node point to the node that just got created? Yes or no? The answer is yes, right? So line 12, basically make node is a pointer which is pointing to the very first node that got allocated. Okay? That's how you continue the code. So now you continue. If you go to line 14, if head equal to null, head is null, right? Remember, initially when we initialized in main, if you go back to main, we initialize head in line 3 to null because there's nothing, right? Because that is the very first node that you got created. Okay, that's the reason in line 14 you check if head equal to null. Then you say make node dot data equal to number because that is the very first node, and we have the address to make node, right? Make node dot data gets the number, and then head now is equal to make node. So whatever address is there in make node which is pointing to the node, you put it in head. So now head is no longer null. So at the end of line 17, in the sequence in which I explained to you, you have created one node, you have put the head to, if I go back to the diagram here, so imagine the number was 4, nothing else is here. You created one node called 4, and this pointer is pointing to null, and then head is pointing to 4. So all that piece of code, you did this part here. That is what you have done. Let me pause here for a second. Questions, comments? Very interesting piece of code. Huh? But again, it's much easier to show you already code that has been written, tested, and all that. But when you yourself write this piece of code, you'll make some syntax mistake. Or maybe in my code here, which I'm showing you, I probably forgot a parenthesis. So the type of thing that you debug. Okay? Okay. Let me go here. Okay. Now, continuing here, if head is not equal to null, imagine now you're putting a second element, right? So we already know make node has the address of that element. Okay. So now you say else, meaning there is a second node. Pretend you're doing a second node. Make node dot data always gets the number. Okay. Now you created a second element. So you're inserting at the beginning, remember? So that's why make node dot next gets head. So head was pointing to the first element. Now that first element is going to become the second element, and the make node is going to become the first element. So that's why in make node dot next you should save head. That's how the second element is linked to the first element. Now what does the head point to? Make node. That's why you see 22, 23, 24. Okay. So what I just explained to you, I wanted to create the first two nodes after we are done with the class. We have time to convince yourself to do that. Go back here. You say that, let me create 4 and 17 using that code. Okay. See how the code works. Okay. That part here. Okay. Now I have also given you code for deleting at the beginning. When you delete, what happens? So after you create the two nodes, then you go through the trace of delete and make sure there's only one node left. Similarly, I did delete at the end. Okay. I did insert at the end. Okay. Notice one thing I said, it's all about manipulation of head, current, and previous. So you see some code here, line 14 and line 22 to 23. Here, all you're manipulating is previous, current, and of course head. Okay. So, and obviously the order in which you do that is important, right? So I gave you the visual representation. I gave you the steps that you need to do, and I also gave you the code that you can use to trace those steps. Okay. So you literally have it all there. Okay. So I say exercise, right? What is the exercise here in the remaining time? and rest of the time after you're done, where you go home and practice this one is, I'm not giving function for counting the number of elements in a linked list. One is counting, the other one is displaying the elements of a linked list. It's just a two-line function, okay? But still, it is at least making you think. Now, once you get comfortable writing these two functions, then I want you to go back and challenge yourself, okay? Challenge yourself, go back to your lab, and then see how many of these functions you can write and execute them successfully. Like how do we insert them before nth node, or delete before nth node, after. I gave you a whole bunch of functions, right? So if you can write, you can be honest to yourself without copying code. Whatever code I gave you, that's good enough to start. If you can write those functions, then I guarantee you, you'll become an excellent programmer. Okay, I'm almost done. I'm going to post this. So, two functions I want you to write and post them in the community, okay? Function count and function display. Next class, when we come back on Monday your time, we are going to talk about how we use this linked list to use polynomial representation. I'm just showing you a brief synopsis of what it means, right? Polynomial has two fields, right? Exponential and exponent and coefficient, right? So the way we do it, every polynomial term, we will create a node. Okay, node has two values, exponent, coefficient. No one said it should have only one value, okay? The node can have two values. First value, second value. Okay? And then the link to the next polynomial term. So here in the example, you can see 3 squared plus 5x plus 7. That's what you're trying to show. So for 3 squared, you can see the first term, first node shows 3, 2. That means it's 3 squared. Second node shows 5x. X is the coefficient of x is what? 1, right? So the second term is the coefficient there. And then you have 7. So 7 has a coefficient of 0, right? 7 times 1 raised to 0, basically. And then that is the last term in the polynomial expression. So since it's the last term, we have the null pointer. Okay? So every polynomial expression can be expressed as a linked list. That is what we are showing here. Now, it was not clear to me from the syllabus one-page paragraph. If I can refer you to a give me a second. It was not clear to me, reading this one, if they want the students to learn how to use this to do, for example, something like a polynomial addition or a polynomial multiplication. Okay? But I'm going to share some code with you anyway as to how to do polynomial addition and multiplication. If it is required, we'll go it in more detail. If it's not required, I'll just show it and then you can learn it on your own. Okay? Usha Garu or somebody can send me an email. Should I cover the code for polynomial addition or multiplication? Then I'll be happy to do that. Okay? Going back to Unit 3 here, reversing is single linked list. We have already done the example in the class 2. Remember I said 1, 2, 3, 4, make it 4, 3, 2, 1. You worked on it. Some of you got the answer. Okay. I will not cover that again. Okay. Depending on what Usha Garu sends me an email, should I cover the polynomial addition or multiplication? I'll cover it in the next class. And then I'll also briefly review the sparse matrix manipulation. By the way, I don't even remember how it is done. I myself have to review that in order for me to teach you. Okay? I forgot all about it. Okay. We'll wrap up the thing in the next class with advantages and disadvantages. For those of you who missed the class, I think you were there, right? We covered this, right?
about in the context of queues. Queues can be implemented as linked lists or arrays, right? Remember? Abstract data type, right? We covered some advantages and disadvantages of them, but I'll cover it more formally in the next class. Okay, that should do it for today's lecture. So here is I'll leave you with the last slide here. Write these two functions. You can play with it in the class now in the next 5 minutes. I'll hang around as always for some more time. You can play with it in the classroom, and if you have questions, put them in the chat and I'll answer them. In the meantime, I'll open up my Lensu and then I'll post this slide deck there in the next 5 minutes. Chakravarti garu, that's it, Andy, for today's lecture. And all of you, what do I call it? Happy what? What is it called? I don't think it applies to boys, but for the girls. Actually, I thought the Varalakshmi Vratam is done only by married women. Maybe I am wrong. Avuna? Acha. Acha. All my mom used to make some nice sweets, gulab jamun and all that I used to enjoy, and vadas and all. Avuna, very nice. Yeah. Amazing, Andy. I look forward to meeting you in person. It will be such a pleasure. Maybe you can teach me something when I meet you. Yeah. I can see that. Great. Neno, let me upload this file. I feel sorry for the people who missed the class.